right, ladies and gentlemen, how are we doing today? We're going to be going into the properties of matter. So, last time we talked about what matter actually is. Matter is everything around us. It is all things that have mass and take up space. This bottle of water and the liquid inside of it. My speaker that's right here. A PlayStation 4 controller. These wireless headphones I have. All these things are different forms of matter. Matter exists in each of these different forms. Now, what we're going to talk about today is the properties of matter. So why are we going to talk about the properties of matter? We're talking about them because we need to learn how we actually describe things. Which, yes, I know, obvious. Oh, it's just a big bottle of water. It's clear. Well, we're going to go into just a little bit more detail so that we understand the different ways that we describe things. That did not work. Boop, there we go. So first things first, properties. Properties are simply put how we describe things. Matter comes in many different forms, and we need to describe them in one way or another so that we can differentiate our different forms of matter from one another. So we use properties. Now, all things have properties. You have properties, I have properties. It's just how we describe things. For example, if you have a friend and you be like, dang, dude, you're short. Him being short is a property of him. That's how I want you to think of it. It's just ways that we describe things. Now, there are two big types of properties that I want to go over. There is one, physical properties, and two, chemical properties. Physical properties are pretty straightforward. The textbook definition of it is you can observe a physical property without changing something into a new substance. The way I look at it for the most part is you can touch something. You can look at it. You can measure it. You can use, for the most part, your five senses to determine physical properties. What does it sound like? What does it look like? What does it taste like? Please don't taste random things. Please don't just taste random things like, oh, that's what my controller tastes like. Please don't do that. So, continuing on my example, here is a PS4 controller that I recently purchased. Now, if I were to describe this, I'd say that it is a dark blue color. I'd also say that the top side of it has a smooth texture, while the back side of it has a slightly rougher, but still mostly smooth texture. If you ask me how much it weighs, I'd say it's pretty light, nothing too crazy. If I had an actual scale, I could put this on the scale and figure out the exact number it weighs. I have a ruler. I can measure it. I can measure this and find out that across the top of my controller, it is a little bit more than 5 inches. And across the bottom, it is right around 6 inches long. These are all physical properties. The big thing is, notice how I didn't actually change what my controller is made out of to determine any of this. That is the important point with physical properties. Whatever your stuff is made out of doesn't change when you're determining them. Chemical properties are a bit different. A chemical property is something that can only be observed by observing a chemical reaction. So, without going into too much detail, chemical reaction, you start with one thing or even two things, and you end up with new things. That's how chemical reactions work. So, in this case, a chemical reaction would be something like, oh, I burned a paper and I got ash. That ash at the end is a new product. It is a new material. So we observed a chemical property. That paper was able to burn, or it was combustible is the scientific term. Chemical properties come in many varieties. A lot of them, it's like, oh, blank reacts with water. Blank reacts with oxygen. These are chemical properties. The word react in the description of the property, easy chemical property. A few other ones is it rusts, or you'll see the word oxidizes. That's another chemical property. I'll just write rusts for you guys to make your life easier. But the technical term is oxidize, but that's fine. So if you see reacts with anything, it combusts, it oxidizes. These are all chemical properties. Now, talked about properties. This is also the last slide for anybody who's counting. So we talked about chemical properties and physical properties. Speaker, shut up. Nobody likes you. As I throw it across the room. So there are two So we're talking about changes in matter. So matter doesn't stay the same all the time. Things break, things change. And this is just part of life, honestly. Well, when things change, there are two types of changes that can occur to an object. You either get one, a physical change, or two, a chemical change. So these are two types of changes. What is the difference between them? Easy part, physical changes. You see the sticky note? Oh, excuse me. You see the sticky note in my hand? It is made out of paper. I rip it. Is this still paper in my hands? Yes. Yes, it is. Is it the same size paper? No, it's not. But it is still paper. It just underwent a physical change. The important part of physical changes is you do not make a new substance. Your stuff that you had initially did not change. So we had paper. We ended with paper. It looks different. That is a physical change. Chemical changes are different. Chemical changes require you making something brand new. So typically what happens is chemical change, you'll mix one thing with another thing and then boom, you'll get a new thing. Or you'll have one thing and you'll do something to it and you'll get two new things. Whatever happens, chemical changes require you start with something and you end with something different. Going back to what I said before, if I took this piece of paper and took a match and just went whoosh and lit it on fire, I would get ash from that. Ash is not the same as paper. So that is a chemical change. So me burning something is a chemical change. Another example of a chemical change is if I were to take vinegar and baking soda and mix them together. When they mix, what would happen is you'd see bubbles come out. Those bubbles show us that a chemical change has occurred. If you're not sure if a chemical change happens, there's a couple easy ways to figure it out. Number one, did you see a color change? Number two, did something bubble when you mix them together? And number three, was there like a weird smell or like a massive change in like the color and the look of something? So what I mean by that is if you took a piece of paper and burned it, number one, you get the smell of burning paper. That smell tips you off that something's going on. Number two, it would look like this and then be like black and gray, just very light, really flaky materials. Chemical changes occur. You'll have like a massive change in the properties of something. You'll have to describe it in a completely different way. Physical changes, you only have to change like one or two things about what you said. Now, as a quick little aside, I'm going to jump back for a second. Boom, hey, look, chemical properties. Your chemical properties, to observe a chemical property, a chemical change must happen. It's that simple. If you don't have a chemical change happen when you're testing for it, then you don't have that chemical property. It's that simple. All right. I hope that I managed to go through this pretty quickly. If you have any questions, of course, you can comment below. You can email me. I will respond as quickly as I can. Do me a favor. There's a Google form. It's got some questions in it. Won't be too many, just like last time, where there's only about seven or eight of them. I'm going to do about the same number. So please make sure you get those done. Please make sure you check it off that you did it and hit that little turn in button so I know that you finished the work. Thank you guys. Have a good night. Bye-bye-bye.